This isn't alive, but it suddenly starts growing like it is. No cells, no DNA, just chemicals building structures by themselves. And somehow, the reaction keeps rebuilding itself. So why does simple chemistry look disturbingly alive? It starts with something extremely simple, a crystal dropped into liquid. At first, the reaction looks completely inactive. Then suddenly, a strange membrane begins forming around it. And inside that membrane, pressure starts building almost immediately. And then, the structure suddenly explodes upward. Not randomly. The reaction starts organizing itself into patterns. And this is where it starts looking uncomfortably biological. But then something even stranger happens. It starts rebuilding itself. The liquid keeps flowing through the structures, almost like circulation. And the more it grows, the more alive it begins to feel. Wait, why does the reaction keep repairing itself? And why do the structures always grow upward against gravity? Because technically, this shouldn't look this organized. So how does simple chemistry build something that looks almost alive? Now the reaction starts spreading everywhere at once. Different chemicals create completely different structures. And the pressure inside keeps breaking the structures apart. But somehow, they immediately rebuild themselves. The structures aren't solid. Liquid keeps moving through them. And this is where chemistry starts looking disturbingly organic. Because these structures behave less like crystals and more like systems. One rupture can suddenly create an entirely new structure. And the larger the network becomes, the faster it starts expanding. Some structures even compete for space as they grow. Wait, why does the liquid keep flowing upward inside them? Because technically, none of this should look alive. The structures don't grow once, they constantly destroy and rebuild themselves. Because pressure inside keeps searching for a way out. And inside the tubes, the liquid never fully stops moving. At this scale, chemistry starts feeling strangely alive. But then the reaction suddenly changes behavior completely. Instead of climbing upward, the structures begin spreading sideways. Separate reactions suddenly connect into one massive system. And now, the liquid starts moving through all of them together. Wait, why does the reaction keep adapting after damage? What you're seeing isn't biology, but it's behaving disturbingly close to it. And this becomes important later, because scientists notice something unexpected. Some researchers think reactions like this may resemble the first steps toward life itself. Everything begins with a membrane, a microscopic wall forming around the crystal. But the wall isn't completely solid. Liquid can still move through it. Water keeps rushing inward, and pressure inside starts rising extremely fast. Eventually, the membrane can't hold the pressure anymore. So the escaping chemicals build new walls around themselves instantly. And the pressure keeps pushing the structures upward again and again. But here's where the reaction becomes genuinely strange. The branching patterns aren't fully random. The system starts distributing liquid through the entire network. And damaged areas can sometimes rebuild themselves automatically. If you think this looks biological, scientists notice that too. Because these reactions behave less like static objects and more like active systems. Wait, what if early chemistry behaved like this too? Some researchers think reactions like this may have existed on early Earth. Long before biology existed, chemistry may already have been organizing itself. And that possibility changes the entire experiment completely. Different chemicals completely change the way the structures grow. Copper builds dense structures that spread like underwater coral. Iron grows differently, sharper, faster, more chaotic. But everything changes when multiple reactions collide together. Now the structures stop behaving like isolated reactions. The entire network begins sharing pressure and liquid flow. And one rupture can suddenly destabilize the entire system. At this point, it barely resembles simple chemistry anymore. Because the structures begin behaving more like connected systems. Even collapse becomes part of the growth process. The reaction almost develops its own rhythm. And this is the part nobody expected from simple minerals. If you saw this without context, you might assume it was alive. But everything you're seeing follows the same physical rules. Pressure, diffusion, and chemistry organizing itself. And somehow, that becomes strangely difficult to separate from life. At first, this looked like nothing more than beautiful chemistry. But inside the structures, energy never completely stops moving. And billions of years ago, Earth may have looked disturbingly similar. Because before cells existed, nature may already have been building containers for life. Membranes, pressure, circulation, division. The line between chemistry and biology starts becoming dangerously thin. And maybe life didn't suddenly appear. Maybe it slowly organized itself. What you're seeing may resemble one of the earliest steps toward complexity on Earth. And the strangest part is, it all begins with simple minerals in water. And once you see it this way, the experiment becomes impossible to forget. But eventually, every chemical garden reaches the same ending. The pressure disappears, the flow stops, and the structures slowly die. But another experiment behaves completely differently. What if a liquid suddenly stopped behaving like a liquid the moment you touched it? A substance that becomes solid under force and liquid again seconds later. Next time, we touch a liquid that defies gravity itself.